how to solve a problem if a client comes in and says they want a specific level of risk. Of course, a client won't know how to put that in terms of standard deviation, but once you figure out that your client should take a particular level of risk, in this case, let's say that the standard deviation they should get is 20%. That could put them at this point with about, what's that, about 5% return, or up here with somewhere between a 10 and 15% return. So I want to be able to figure out precisely how to get that solution. So in order to do that, I want to give a little background math. So the background math is going to be this. You remember the quadratic equation from your high school algebra classes. Y is equal to ax squared plus bx plus c. And if you do that, you're going to have an equation that looks something like this. In this case, it's 2x squared plus 4x minus 15. How do I solve for that? I use a quadratic equation, which is given here. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And that's going to give me the x-intercept, which is going to be right here and right here. I can see there that's like almost minus 4, that's almost positive 2. So you can see that this shape of this quadratic equation looks like the envelope portfolios here if you would just twist it 90 degrees, right? So the math we're going to use is the same. So what I want to do here is find the quadratic solution first, and then I'll do it for this one. So over here, x is going to be equal to negative b, which is minus 4. Let's do plus first, plus the square root of b squared, which is going to be 4 squared minus 4ac. So that's 4 times 2 times negative 15. All that's going to be divided by 2a, so that's 2 times negative 15. So x is going to be equal to, x will be equal to minus 1.915, which is, I'm sorry, not minus, positive. Let me erase that. I don't know how to put the minus. That'll be positive 1.915, which is this point right here. So call this x1. x2 for the other point is going to be negative 4 minus the square root of 4 squared minus 4 times, and this 4 is not related to that, to b, 4 times 2, which is a, times minus 15, which is c, over 2 times negative 15, and that's going to be equal to minus 3.915, which is that point right there. Okay, so that's what you've done in the past in a high school class. Now let's get, well, I'll leave that up, and we'll come over here and talk about how to solve this. Well, I know that, let me change colors here. I know that the variance of a portfolio is equal to the weight in x squared times the variance of x plus the weight in y squared times the variance of y plus 2 times the weight of x, weight of y, sigma xy. So as you recall, when you graph this, you had, a weight x and a weight y. You got those points, and that gave you the sigma for the portfolio and the return for the portfolio, and you graph those. So the formula you used to get this was just the square root of that. So I need to solve this for wx, because I want to know what weight in wx is going to give me a portfolio that's here or here. Well, I know that the weight I put in x plus the weight I put in y is equal to 1. I need to know both of those points. So if I do that substitution, this implies that the weight in y is equal to 1 minus the weight in x. So sigma p squared is equal to wx squared sigma x squared plus 1 minus wx squared sigma y squared plus 2wx 1 minus wx sigma xy. So that's going to be sigma p squared is equal to wx squared, sigma x squared, plus, when I expand this, that's 1 minus 2wx plus wx squared times sigma y squared plus 2wx sigma xy minus 2wx squared sigma xy. So sigma p squared is equal to wx squared sigma x squared plus sigma y squared minus 2wx sigma y squared. So I'm multiplying this 1 times that, then negative 2wx times this, plus wx squared sigma y squared. I'm running out of space here. Plus 2wx sigma xy minus 2wx squared sigma xy. Let me move this up a little bit. And that's going to give me, I'm going to write it down here so I can drag something up in a minute. That's going to give me sigma p squared is equal to, see if I can drag that. Let me just erase this real quick. I need to have this where I can see it just a little bit better, where you can see it a little bit better. So here, sigma p squared is equal to, I need all the terms that multiply by wx squared plus all the terms that multiply by wx plus all the other terms. And actually I'm going to have this set equal to 0, and I'll have to drag that across. Okay, so go back to blue writing here. For this, here is a wx squared term, so that's sigma x squared. Another wx term is right here, so I add sigma y squared. Here's another wx term, so that's minus 2 sigma xy. And then the wx terms, there's one right there, that's 2 sigma xy. And there's another one that's minus 2 sigma y squared. And this term doesn't have a wx with it, so that's sigma y squared. And then I need to drag this one across. That's minus sigma p squared. Alright, now let me drag that up. That's pretty much out of the way. Okay, so how to actually handle this? Well, I need to know where this came from. And I'm going to pause the video and clean some of this up real quick. Okay, so when I drew this line right here, how did I do that? Well, I had to know the following. I needed to know the return and the risk. So I had, asset here, X and Y, and I had the return, and I had the volatility, and the return on asset X was 13%, and its volatility was 0.2. This is an example that we've done in class before, I think, with these exact numbers. Y had a return of 8%, sigma Y was 0.12, and the covariance between X and Y, the covariance between X and Y was 0.0072. Okay, so now I want to go back and I want to find these points. How precisely do I do that? First, I need to find the weights. So this term is like, this is like A, this is like B, this is like C. So for my A will be equal to 0.2 squared plus 0.12 squared minus 2 times 0.0072. B will be equal to 2 times 0.0072 minus 2 times 0.12 squared, and C will be equal to 0.12 squared minus 0.2 let me do a different number other than 0.2 because that's already in there. Let's say that's a bad example. So let's say the client, rather than wanting a 20% return, let's say the client wants a 15% return. So 15 is right about there. That would put them at this point and that point. So the client, you'd have to come here and say the client wants a volatility, not return, a volatility of what? Let's say 15%. Where do I get that? I get that from a discussion with the client and saying, well, based on your personality, your situation, we believe the risk that you're able to tolerate is a portfolio that has a volatility of 0.15. So that's 0.15 squared. Solve for A, B, and C and plug back into the x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And that's not really x right there. That's really, in this case, wx. That's wx that you solve for, and wy is equal to 1 minus wx. Now that you have those weights, you can know the return. The return for the portfolio is equal to 0.13 times the weight in x that you just found, plus 0.08 times the weight in y that you just found. So now you can tell the client, let's say, I don't know what these numbers come out to be. Let's say this comes out to be 60% and 40%. Well, once again, I don't know what the numbers turn out to be. So if that's the case, you're going to say to the client, look, you take 60% of your portfolio, put it in X, and 40% of your portfolio and put it in Y, and the return you're going to get is going to be whatever this comes out to be, and the standard deviation, the risk you take, is this 15%. Okay, you do a plus and a minus, so maybe that was when I did the plus. And then if I do it with minus, instead of getting 60%, maybe I get 30% and 70%. So then 30% goes in here, 70% goes in here. See which one has the highest return, and you want the one with the highest return. Now in this case, I can tell you the one with the highest return is one that has the most weight in X, because portfolio X has the highest return. Okay, so hopefully that's clear. Now that I'm going to put up a video showing me going through this in Excel with the actual numbers that we've had in class.